Welcome to Think Before You Code. Today we are going to discuss ownership and borrowing in Rust. This is a topic that I find personally interesting. Ownership and borrowing are central concepts in Rust, and understanding how they work is essential for writing correct and efficient Rust code. So, what is ownership? In Rust, every value has an owner, and that owner is responsible for releasing the resources associated with that value when it is no longer needed. This helps Rust avoid the problem of dangling pointers and memory leaks, which can be a common issue in languages with more permissive memory models. If you're learning Rust, you've probably heard a lot about ownership and borrowing. But why are these concepts so important in Rust? First of all, ownership and borrowing help ensure memory safety in Rust. In languages without a strict ownership model, it's easy to create dangling pointers or memory leaks, which can lead to bugs and security vulnerabilities. By enforcing rules around ownership and borrowing, Rust can ensure that these kinds of issues don't occur. In addition to improving memory safety, the ownership and borrowing system in Rust is also designed to be lightweight and fast. Because Rust knows the ownership and borrowing relationships between values at compile time, it can often avoid unnecessary allocations and take advantage of optimizations like inlining and constant propagation. This helps make Rust code efficient and performant. But ownership and borrowing aren't just about performance. They also play a crucial role in Rust's support for concurrent and parallel programming. By enforcing rules around shared access to data, Rust can help prevent data races and other synchronization issues that can be difficult to debug. This makes it easier to write concurrent and parallel code that is correct and performant. In short, the ownership and borrowing system in Rust is an essential part of what makes Rust a safe, efficient, and scalable programming language. It's definitely worth taking the time to understand these concepts if you're learning Rust. Here's an example of ownership in action. In this example, we have two functions, takes ownership and makes copy. When we call takes ownership and pass it a string, the value of that string is moved into the function. This means that the original string is no longer valid in the calling function. On the other hand, when we call makes copy and pass it an integer, the integer is copied into the function. This means that the original integer is still valid in the calling function, because integers implement the copy trait in Rust. So, what about borrowing? Borrowing allows you to use a value without taking ownership of it. There are two kinds of borrows in Rust, immutable borrows and mutable borrows. Here's an example of borrowing. In this example, we have two functions, calculate, length and change. Calculate length takes an immutable borrow of a string, and change takes a mutable borrow of a string. An immutable borrow means that the borrowed value cannot be modified through the borrow. In calculate length, we can use the borrowed string to calculate its length, but we cannot modify it. A mutable borrow, on the other hand, allows the borrowed value to be modified. In change, we use the borrowed string to append world to it. It's important to note that Rust enforces rules to ensure that borrowing is safe. For example, you cannot have multiple mutable borrows of the same value at the same time. This helps prevent data races and other synchronization issues. I hope this tutorial has helped you understand the basics of ownership and borrowing in Rust. Thank you for watching.